Alrighty, so if we look at this first one, you can see straight away that x and y can't be 0 because 0 is not greater than 0. So we might, put a little thing there, just an empty point there. Also, if you forget about the inequality for a second, just pretend it was equals, you'd have y equals x, or y equals negative x, or negative y equals x, which is the same as y equals negative x, or negative y equals negative x, which is the same as y equals x. So you get all those different lines, and we know y equals x is our straight line that way. Now, I'm just paying attention to the inequality now. It's not equal to, so I'm going to do dotted lines. So that's our y equals x, and I'll put in my y equals negative x here, but of course dotted lines. All right, so then you can see we've got 2, 4, 6, 8 regions there to check. But we can do it by quadrant, because if I look at the first quadrant where both y and x and y are positive, so if I look over here in this first quadrant, they're both positive, so I'm looking at where y is greater than x. Now you can choose a point, but clearly it's going to be here. But if you're choosing a point, for example, we would go across 1 up 2 and check, is 2 greater than 1? Yes, it is. So we've got this quadrant here. All right, so if I'm looking, let's say down here, we've got, this is where x is positive and y is negative. So if y is negative, I'm going to need the negative in front of it to absolute value it. So instead of writing absolute values, I can write negative y just for this section, and is greater than x is positive, so I don't need the absolute value or the negative there. So if I just multiply through by negative, that changes the sign of the inequality. So y has to be less than negative x. So if it's confusing, especially for the negatives, choose a point carefully. So for example, let's choose, well, we could choose both. So if I chose a point over here in this section, so let's say across 4 and down 1, you can see here I would be going, is negative 1 less than negative x negative 4? And remember, negative 1 is here, negative 4 is here. So actually negative 4 is less than negative 1, so that doesn't work. So let's check here. So let's check across 1, down 4. So this time is negative, let's go again. So what's y? Negative 4. Is negative 4 less than negative and x is 1? Yes, it is. So we know we are going to shade in that area. Okay. All right, so looking at this quadrant over here, or let's just, looking at that quadrant, both our x and our y are going to be negative. So we need, instead of the absolute value, I'm going to put a negative in front of both to make them positive. So again, dividing or multiplying through by negative will change that sign. So now we're looking for where y is less than x. So if I choose a point down here, so for example, negative 1, negative 4, I'm going to have the y is negative 4. Is that less than the x, which is negative 1? Oh, yes, it is. So we're down here. If I chose something here, for example, negative 4, negative 1, you would see that now I've got negative 1 there and negative 4 there, which is incorrect. Negative 1 is not less than negative 4, right? So that's not shaded there. So you can imagine where it looks like we're going to shade. So I'm just going to check a point here. So across negative 1 up 4 perhaps. And in this quadrant, both, the y is positive, so I don't need to use that absolute value. I'll put a negative in front. And the x is negative, so I'm going to negate it to, instead of using the absolute value. So y is greater than negative x. So if I put negative 1, 4 in, I've got negative 1 is greater than negative 1, which is positive 1. Did I just put the wrong? Sorry, y is 4. Okay, so y is 4 and x is negative 1. So that becomes negative 1, which is positive 1. So is 4 greater than 1? Yes, it is. So I know I want that section. All right, so I'm pretty sure that's, I could check another point, but that's what we've got there. So if I look at B, again, if I'm just looking for, forget about, it is an equal sign, so I don't have to do the dotted lines. And here we've got, if I forget about the absolute values for a second, I've got xy equals 1, so, or y equals 1 on x is the same thing. So remember that is just our hyperbola, like, whoops, like so. And so, for example, 1, 1, if x and y are both 1, that is equal to 1. So, 1, 1 definitely works. So anywhere on this line is going to work. Or -1 times -1, that is definitely going to work as well. Okay, so those points work. So I'm really looking for, and I can see straight away that if they were both 0, 0 times 0 is not greater or equal to 1. So I know that inside point's not going to work. So, I'm fairly sure that I could choose a point that outside this bit is going to work. But just remember also we've got those absolute values. So that x and y can both be positive, both be negative. One can be positive, one can be negative. So if we've kind of got one of them negative, we would have y equals -1 on x. So we also have this, the second and fourth quadrant branches to look at. And again, I'm fairly sure it's going to be here and here, but let's check. So for example, we could just check a point here, let's say 4, -4, 4, -4, and pop that in. So x is 4, y is -4. If we absolute value that, we've got -16, absolute value of that is 16. Is 16 greater or equal to 1? Yes, it is. So that point works. All right, so you can just check some points. It's probably easier for that one there. And then for the last one here, it's an interesting one. We've got 1 on x is greater than 1 on y, and you might say, oh, I can just multiply both sides by xy, and I would get y is greater than x. Why can't I just do that? So you can if x and y are both positive, because then the inequality sign would hold that way. But if we're multiplying or dividing through by a negative, the inequality sign would change direction, and we're not sure of that. So in this quadrant here, we would be looking at y being greater than x. And if I just change that for a second to a equal sign, y equals x, I'm looking at this line again. And of course, again, y and is not allowed to, they can't both be 0, because that is a point that's where y equals x. But think about if I'm doing negatives. So if both are negative, I'd still get my y equals x. But if one of them is negative, then I would get my y equals -x. So I need both of these again. Okay, so as we were saying, for that first quadrant, when our x and y are both positive, we can just multiply both sides by xy or yx, and we'll get y is greater than x, which we know is in that quadrant there. If we have, for instance, over here, we've got our x is positive, and our y is negative. Actually, probably easier if you want you could just check points as well. So we could just go over here again and go, okay, 4, -1. If I put 4, -1 into the actual equation, I've got 1 on 4 and 1 on -1. So is a quarter greater than -1? Yes, it is. So I know that I want that shaded. Over here, we could go 1, -4, and again pop that in. So I've got 1 on 1 this time, which is 1. Is that greater than 1 on -4? Which it is. So we've got those two. So this is looking like a weird one. If I choose a point over here, so -1, -4. So now I've got -1. Is that greater than -1/4? No, it's not. So I'm not going to colour that one in. Let's check over here. So -4, -1. So negative. So remember, I'm checking in here. So -4 being the x, is that greater than negative and 1 on -1? Is that greater than -1? Oh, it is. So that one I can colour in. So you can just keep going around like that. If I check a point here, so -1, 4, for example, in here. So -1, 4, is -1 greater than, no it's not, so I'm not going to colour that in, shade that in. And here -4, 1, so I'd get -4, 1, is -1/4 greater than 1, no it's not, so I'm not going to shade that in. So it's just these kind of 4 sections that we're shading in. So often just choosing a point, very handy to check.